the golden proportion, the golden section, the divine mean, the harmonic proportion, dynamic symmetry, however you call it, by whatever name, it's everywhere. This proportion's been around since the beginning of time, and we see it in all kinds of places. We see it in the way plants grow. We see it in phyllotaxis, which is the structure of growth. We see it in pine cones. We see it in sunflowers and how the sunflower seeds grow. We see it in ram's horns, seahorses, elephant tusks, antelope horns, boar tusks, cat's claws, all different ways. We see it in hurricanes. We see it in spiral nebula. We see it in the human form. And this is the proportion we're looking at here. So just sort of pay attention to that. It's the ratio of 1 to 1.618, and we'll come back to that. We can see it in the way the structure and the proportions of the arm. There's your ratio right there. We see it in the proportions of the human body. Lots of people have tried to figure out lots of different ways of finding this proportion within that human body. And the golden ratio. How does it work exactly? This actually, the backstory of this goes back about 5,000 years to the ancient Egyptians. They were the ones that sort of started looking around and figuring out that there seemed to be some kind of innate proportion in the human body and also in the way things grew, as we saw. And one of the things that, of course, they had to do was they wanted to build the pyramids, amongst many other things. And in order to build, structures, you have to have mathematics and you have to have measurement. And so they started determining, well, if we use the emperors, or the pharaohs, I should say, if they use the pharaoh's body as a way of developing, a measurement system, then they could then extrapolate that into larger and larger structures. So we can see that they used the pharaoh's body size, and this is actually a drawing from the modular, which we'll see in a minute, looking at how the dynamic proportions related to the structure that the Egyptians were coming up with. We see it here again, and we see that as it relates to the phyllotaxis growth proportion. After the Egyptians, the Greeks then picked this up from the Egyptians by trade, and they took it quite a bit further. The Egyptians were a little bit on the crude side, but they had seen it and they'd figured it out. And then the Greeks really took off with it and started to really develop a very involved measurement system based off of this golden section. They used it in their sculptures. They used it in their pottery and in their ceramics. And actually, they used it in their architecture. And then the Romans took over. And so now the golden section kind of starts to go into this lost and found kind of phase, where it was found, then the Romans came on, and they lost it. They didn't really ever quite figure it out. And they base everything off of the square, which is only part of the golden section. And essentially what ended up happening is that they lost the proportion. And being amazing engineers and amazing architects, they built a lot of really great things, but their architecture and their sculpture tended to look a little bit flat. And of course, once the Roman Empire fell, then all that information was lost for eons, for generations. And so it took another few hundred years after the Dark Ages, and then we got into the Renaissance and in the Middle Ages, and they started to rediscover this. And whether they found scrolls from the sacked library at Alexandria or whatever, we're not really sure. But they started figuring out that that proportion was around again. Here's the golden section. Okay, it's developed from a square, and we'll talk a little bit about this in a minute. And you can see the spiral. It's a logarithmic spiral, and it's infinitely scalable. It goes all the way. It can scale all the way down. It can scale all the way up, as we saw. It can go from hurricanes to spiral nebula, and down to the molecular level. Here's a cute little cartoon, and I'll let you just sort of read that, right? One cheesy tortilla chip, and anyway, it ends up being a Fibonacci's. Anyhow, long story short, Fibonacci series is a series of musical structures, and it's mathematical, and this is how it works. And I'm not going to get into all the science. I just am trying to show you that there's a lot of different ways that this proportion has been found and extrapolated on. For example, the Stradivarius violin, we find those proportions all over the place. And the human body, we talked about that. Leonardo da Vinci took it quite a bit further. And then we start seeing it in Renaissance paintings, and they start using the proportion to develop both perimeters and also the relationship of body parts. We see it in their in murals. We see it in the architecture. More architecture. And then this is where I picked up on it. I was exposed to the guy named J. Hambidge. He was a mathematician around the turn of the last century. And he, as amongst other great mathematical things, he developed a system for analyzing Greek pottery. And it turns out that if his calculations are correct, the Greeks really did give a lot of thought to how they were building their pottery. And so he took a picture and then he analyzed it and then tried to figure out whether those parts worked or not. And so he called the golden section the whirling rectangle, which is what the W's are. And then he started playing around with root rectangles, and we'll get into that in a minute as well. And trying to see if they developed like structural, ways of developing their their pottery. So you can see he did a lot of work just analyzing things. Then it got lost a little bit again. It sort of fell apart, and then it got picked up again by the Bauhaus, and they started working with it. And you can see Joseph Müller Brockmann, he's kind of the king of grids, and he developed very complex grids based off the golden section. And so we can see the proportions and the different ways the circles are spinning around. You can see the grid that he developed there. So we're talking about grids. This guy was, like I said, the king of grids. I mean, you could just look at his grid structures, it's just crazy. And I apologize for some of the low quality scans on these. I scanned these out of a gallery brochure that I have, and some of the images just were too small to come up accurately, but still you get the idea. So, King of Grids, having a good time, golden proportion, we see that right in here. There's the 1 and there's the 6.18, and it's all over the place. Then an architect named Le Corbusier, he took it a step further into a concept he called the modular. The modular was something that he felt was important. He was an architect primarily, amongst other things, and the measurement systems in Europe and most of the world are based off of the metric system, which is based off of the meridian measurement of the Earth, which, you know, it can work obviously, but he felt it was a little too rigid for creating human scaled buildings. And the foot and inch system is also human scaled, and it works, except it's very cumbersome, right? He's got the inch, the foot, the yard, and so on. And he wanted to come up with something where it was based off the human proportion, the dynamic section, but he wanted it to be more like a ruler. And so he worked through all these different processes, looking at how people see the scale that we see things at. It was seeing if, you know, the proportion was there. He just kind of worked through a lot of different ideas. And then he started coming up with this measurement system, you know, based off of the positions of the body in space. And so it continued on where he started to refine this. And this is, you can see the scale there. And that's where the modular ended up. And he was trying to get this to be accepted by the International Standards Organization, and was getting pretty close. And then World War II broke out, and that effort was dropped and never picked up. But we can see the golden section being used in modern design. The Toyota logo, we can see the golden section here, here, here. So it's all over the place there. We can see it's in letter forms, primarily, you know, in this sort of, you know, situation. And you have to ask yourself, is this pushing things too far? And it might be, but it's still trying to find a rationale for making decisions, right? And so the DIN paper size is based off of the golden section. A4 is the size of the standard 8.5 by 11. Our standard page size there is A4, but these are all golden sections, and you can see that every piece of the puzzle is proportionally larger, so it's kind of cool. We see it in the in automotive design. This is, I believe, an Aston Martin, and you can see the golden section. They're trying to come up with different ways of applying it as a ruler to create proportions between parts. Pretty cool stuff. Used in the Apple logo, and of course the iPad. And then they started going into financial investments and taking off on the idea of the Fibonacci series in terms of when it's a good time to sell or buy. We might want to take a look at that in this particular day. And then getting into a little bit of humor with the Crony Pyramid, and then a little bit more metaphysics, and you can really go off on that. That gets pretty crazy. And then, of course, we get to the final stage of the development of fractal geometry based off of the golden section. And we're going to pause this for a second. If you really want to blow your mind, let's take a look at some fractal geometry computer-generated graphics, and you'll get this is all based off the golden section and how it's scalable. And once you kind of start getting into this, it gets insane. And it's been said that this is the thumbprint of God, which is a kind of a cool way of thinking about it. And as well, they say that if you study this proportion long enough, it'll fry your brain. And as you start really getting into the idea of this, if you really start studying it, you will fry your brain. It is unbelievable how deep this concept goes. And so if you want to have more fun than a barrel of monkeys, go ahead and Google, go to YouTube and go to Fractal Zoom or Mandelbrot fractals or something to that effect, and once you're there, you'll get dropped into all kinds of a huge black hole. So anyway, this is the concept that the dynamic grid is based on. And as you can see, this goes on and on and on forever. And what we're doing here with the dynamic grid is just one small part of a massively huge universe. So we'll have fun with our small part of that. Cool.